As always, good morning, ladies and gents. I wanted to make a video from the summer school day 6, which was yesterday, July 20th, about how to do writing equation or slope equations. Okay, and yesterday we started with writing slope equations from tables, and today we'll be doing them from graphs. But for yesterday's writing slope equations, we had a vocabulary slide. And I left some of what we talked about up. So it's like proportional means it goes to the origin. The 0, 0. The y-intercept is when x is 0. And at any point when the line crosses the y-axis. Right? The difference between proportional and y-intercept is that y-intercept can be 0 any number. So for example, like if I said when x is 0, the y-intercept can be at 0, 1. Okay, but the y-intercept can also be at 0, 2. It could be at 0, 3. It could be at 0, 100. It's whenever x is 0 and it crosses the y-axis. That would be the y-intercept. Okay, and whatever number we get that for that y, like if it was 0, 100, then to our equation, we would be adding plus 100 at the end. If it was negative, let's say it was negative 100, we'd put negative 100. All right. So anyway, slope is steepness, or it's the change in y over the change in x. Some people prefer the term rise over run. And then we're working with equations today, and an equation is any math problem with an equal sign. Yes, that means even back in like first grade when you did 1 plus 1 equals 2. That's an equation because it has an equal sign. Okay, in today's world, or for today's learning, we are using the equation y equals mx plus or minus b. Now this is slope because it has slope components, but it also has an equal sign right here, which makes it a slope equation. So from there, we created that slope equation from these graphs. Okay, so we're going to need slope, we're going to need y-intercept, and we're going to need equation. Now slope is the change in y over the change in x. Here I have a y, 3 to 6. I need to find the change in this y and then place that over the change in this x, and here the x's are, to find my slope. So I'm going to use these little handy arrows. I created them in advance just to make this video a little easier. So I need to ask myself, what is the change in y here? How do I get from 3 to 6? What is the difference here? And you would tell me 3, because 3 plus 3 makes 6. So I'm going to insert a text box right here and type plus 3. That is my change in y. Now, my next concern is, well, what's my change in x? So I'm going to insert another arrow, and this one is going to represent my change in x. Oop. Now, how do I get from 4 to 6? You would tell me plus 2. So I'm going to borrow this little text box up here and put plus 2. Why did I do that? Because 4 plus 2 makes 6. Oop, I typed 3, sorry. Alrighty then, I now have a change in y. My change in y is 3, and my change in x is 2. Therefore, my slope is 3 over 2. Okay, if you prefer decimals, which I do not recommend, but if you do prefer them, you could type that as 1.5. If you're wondering how I got 1.5, in your calculator you could type in 3 divided by 2, and you will get 1.5. Alrighty then, I now have one part I need for my slope equation, but I still need the y-intercept to make the slope equation. Going back to our definition, y-intercept is when x is 0, when the line crosses the y-axis. When x is 0. Well, here, we don't have 0. Okay, on our x, we don't have that at all. So we're going to have to go backwards to get it, because if we go forward, our numbers are increasing. So we need to go backwards where they're decreasing. So instead of adding, I'm going to do the inverse or the reverse operation. Okay, so instead of adding 2, I'm going to go backwards 2. Alright, so I have a new arrow, and I'm going to copy this. Now if I go back 2, and I'm going to go ahead and change this color to like red, just so we know I'm going negative. Okay. If I go back 2, 4 minus 2 is 2. So I'm going to have to do that again to get back to 0, because again, the definition of the y-intercept is when x is 0. So if I do that one more time, okay, I will finally get to 0. That means I'm going to have to go backwards on my y twice as well, right? So let me do that. So right now I was adding by 3, so I'm going to subtract by 3. Okay, so I'm at 3, I go backwards 3, I'm at 0. And if I go back again, oops, sorry. If I go back again, I'm at negative 3. So let me put my first one minus 3. And again, I'm going to turn that red just so it's easier to see what I'm talking about. Okay. And then minus 3. This will put me at x is 0, because again, I'm over here starting at 4, and I went back 2, so I'm at 2. And I go back 2 again, I'm at 0. And then over here, I'm at 3. I go back 3, I'm at 0. And I go back 3, I'm at negative 3. So my change in my y-intercept would be 0, negative 3. The ordered pair of 0, negative 3. Probably the hardest thing about all that is that it's just obnoxious, and sometimes you have to move more than once. And then, ironically, an ordered pair is x and then y, but slope is y over x. I have no idea why they did that. Okay, but that's how it is. So for our equation, we just put it all together. On all of these, it's y equals. Technically, through this whole assignment, you could go put y equals on every single one, because that's how they'll all begin. Okay. But going back to what we're talking about, y equals whatever your slope is. So in this case, 3 over 2. You put an x after that, and then your y-intercept number, negative 3 or minus 3, however you want to say that. You are now done. You would follow the same pattern for 2 and 3. However, all the teacher freebies that I did live were probably the harder problems, most of the harder problems. There are still 1 or 2 out there, but these get a little easier, and I threw a little hint here that if we kept going to the left, our number is decreasing. We keep getting further and further away from 0. So for this one, we had to move forward. Okay, so our slope is still the change in y. So how do I get from 11 to 13? You would tell me plus 2. Okay, well, how do I get from negative 2 to negative 1? You would tell me plus 1. Okay, so that'd be 2 over 1, right? But we still need a y-intercept, which is when x is 0. And you'll see these arrows indicate that going to the right gets us closer to 0. So if I go plus 1, I'm going to be at 0. And if I go at plus 2, I'll be at 15. So my y-intercept here would be 0, 15. All right. I just want to show you an example that sometimes goes forwards instead of backwards. And then for our equation, put it together. Y equals 2 over 1, which is just 2. So y equals 2x plus 15. Oop. If I can type again, there we go. Plus 15. And then be on the lookout for easy ones. Okay, I'm going to jump to number 6. Again, you'll see here, y-intercept is already typed as negative 1. Well, how the heck did I get that? Well, our definition of a y-intercept is when x is 0. I want to highlight that again. When x is 0. Since that's our definition of y-intercept, right here, I'm looking for x is 0. X is 0, the y was negative 1. That's my y-intercept. We only have to do all that work when we don't have x is 0. Okay? So this one's already easy to get your y-intercept, and now you just need your slope. And of course, put it together in the equation. Alright? This was writing slope equations from tables. Our next one will be writing slope equations from graphs. If you have any questions, come attend tutoring hours. I'm here for you as always. Email me, message me, text me as I put in the Google Voice. As I put in the class introduction presentation. Okay, my Google Voice number is there. Want y'all have yourselves a great day. Don't forget that Maya Angelou said, do the best you can until you know better. Then when you know better, do better. Let's be the change, as Gandhi said, okay? Let's do better, be greater. Why not? Somebody has to be great. Why not you? Have a fantastic day, and I look forward to seeing you in class.